There we go. Welcome to those of you who are joining us on YouTube. Today's session is a senior phase term 2 content look. It should take approximately just under an hour if we go according to yesterday's session. So yeah, let's jump right into it. Oh, for those of you who are attending the live version, please feel free to pop your questions into the chat or the Q&A. I'm always happy to answer them, and I'll try and answer them as they fit in with what I'm covering as well. So today's plan, we're going to look at what is Sharpies if you're not aware of it, and then of course some basics because you always need those, and then what are we going to actually cover today. So decimal fractions, integers, patterns, functions and relationships, exponents, and then algebra. And listen, I can say that like that, but actually algebra is awesome. It's my favorite topic, just so it's a really nice topic to So what is Sharpies? Sharpies is a maths teacher reward program that is just for maths teachers. So you can sign up and earn points for doing things like attending webinars, for telling your students about the Sharp calculator. And then once you have enough points for having a birthday, once you have enough points, you can exchange those points for gifts like earphones and laptop bags and Bluetooth speakers and so on and so forth. So if you want to sign up, tomorrow I will send you a PDF of this PowerPoint presentation, and then you can just click on this link to sign up. And once you've signed up, tell your colleagues and friends about it, and you will also get points for doing that. So it's always a good idea. So some really great resources that we've come across and that I've used personally over the years as a maths tutor. The simulator, if you are still doing online workshops, etc., the simulator is really great. It's free to download, so your students can also download it. Algebra is absolutely fantastic for things like graphing and doing shapes and geometry. So I use GeoGebra to set all of the worksheets from Maths at Sharp. Speaking of, Maths at Sharp has got your grade 8 to 12 maths, math literacy, and technical maths worksheets. And every year we try and add new resources to that. So I'm actually a little bit behind on that, and I will start adding soon once these webinars are completed and the admin for them is done. And then, of course, eClassroom. Just a heads up now on eClassroom, there is a subscription fee. So just FYI on that. But eClassroom is really nice for the primary school phase, and they have all of the subjects. So if you're not just a maths teacher, but a science and teacher, because I know in primary school that tends to go in that direction, and grade 8 to 9 as well. eClassroom is really nice for that. And then, of course, mathdrills.com, really great for lots of extra practice. And then I found, I haven't added it here, worksheetworks.com, really nice for the grade 7s. And what's nice is you can customize your worksheets. So you can choose the number of decimal places, the units that you're using, so when you do an area and perimeter, the types of shapes that you do. So it's, Worksheet Works is absolutely wonderful website. And what's nice is they also have geography and English worksheets. So that's a really handy one to know about. And then, of course, if you still need the ATP documents, these are available on this link. So it's just a summary on our Maths at Sharp page with all the different grades and the ATP documents that you would need for them. They're all PDF'd so that they don't shift and look weird when you download them. Okay, so the calculator that we're going to use today is our favorite Sharp W535 SA. SA stands for Southern Africa, just in case you ever wondered. And then, of course, some important buttons, your mode button, and I'll discuss mode in a second. Your BS button, not what your kids write when they don't know the answer, but backspace, like delete. And then, of course, change, which we'll get into when we do decimals and equivalent fractions. And then, of course, equals as well. So the modes that we're going to use today on the calculator is the normal mode. Then we won't be using stats today. And then, of course, table mode. Table mode is just so epic. And there's so many great investigations that you can use or do using table mode. And in fact, when we get to exponents, I'll tell you a little bit more. So decimals, what do we need to know? So great, you'll see that I've just put who's covering what topics. So grade 7 and 8 we'll be doing decimals in term 2. Okay, so they need to be able to add and subtract decimals. You need to be able to multiply decimals with 2 decimal places by another one with 1 decimal place. And then, of course, divide a number with 3 decimal places by a whole number. And in grade 8, that changes to 2 decimal places divided by 2 decimal places. So there's a really nice function on the calculator that I absolutely love to use. You can see this is from earlier this morning. Which is the random function. And I love using it for all sorts of stuff, but one of the really nice things that you can do is to use it to set up random practice questions. So I am using the random function, so I'm saying second function 7, and I'm just using my first option, which just creates random decimals between 0 and 1 to 3 decimal places. So when I multiply like this, I'm going to get between 1 and 6 decimal places at the end, depending on the size of my decimal. So you can see here, so you can ask them to round off to 3 decimal places, to 2, to 1, or to a whole number. So it'll either be 0 or 1 as your answer. And it's really nice because you can just keep generating stuff. Obviously, you can, you see these ones we can change. So you can see the equivalent fraction as well. So it's a really nice just for practicing those questions, get them to start off with that in the mornings, you know, just a quick brief, and then just switch with their friends and make sure that they are getting the correct answer. You know, something that warms up their brains, just like the mental maths thing on the calculator does as well. Then, of course, you can also look for the equivalent fractions and decimals. So if I have a decimal which is 0.5 and I want to know what the fraction is, then I can say equals, and then it will show me my fraction. I can also put in a fraction and say equals, and then just change it so that it gives me a decimal. Now, what's really cool about the sharp calculator is we've added a recurring function, okay? So to set up the recurring function, we're just going to press setup. We're going to use our down arrow, and we're going to choose 5 for recurring. Now, just on a sidebar here, 6 is the decimal point, and 6 just allows you to change your decimal from a dot to comma. So it's whatever makes you happy. If you would like a comma on your calculator instead of a dot, then option 6 is your option to do that. So let's turn on our recurring decimal. And if I change now, you'll see that it gives me the decimal as a recurring decimal and then as the full decimal as well. So instead of giving you 3 or 4 options, it will now, instead of giving you 2 or 3 options, depending on whether it's a mixed number or less than 1, it will give you 3 or 4 options instead. Sorry, that was quite a tongue twister. Okay, so here's the steps where you can go to turn your recurring decimal on. It becomes really handy for certain things as well. So squares, cubes, and roots of decimals. Just a quick one. So these are your buttons that you would need to use to find those things or to check your answer, because they should still be able to do it with the roots, etc., etc. But I'll just do some with you just so that you have an idea. So if we wanted 3.5 squared, we can just do it like that, and equals. And there we go. What I also want to show you, just as a note, if, for example, you have a fraction and you want to square it, if you just press squared, you can see the square will automatically put the fraction into brackets for you and then do the calculation as well. So it's just a nice thing to know about. And then, of course, if you want the cube root of something, you're going to use your second function and your square root button, which gives you the cube root. There we go. And let's say it's 0.125. And equals, and that is 0.5 or a half, depending on how you would like your answer given to you in the question. All right, great. Any questions with that one? We're all good. You're all awake and alive still. Okay, fantastic. Okay. So the next topic is integers, and for term 2, it's only covered in grade 7. So we are going to look at just a couple of ins and outs of adding and subtracting integers. So the first thing is when your signs are the same, we add the digits and we keep the sign. So when it's both pluses, we add them together. So 7 plus 3 is 10, and the sign is plus, so there's an invisible plus in the front here. When both the signs are minus, again, we just add the digits. So 7 and 3 gives us 10, and we keep the sign, which is minus 10. When the signs are different, it gets a little bit more complicated. I say that in inverted commas because not really. So what we do is we take the small digits, so ignoring the sign, and subtract it from the big digit, and then we keep the sign of the big digit. So if we look at this example, this is plus 7 and minus 3. So my big digit is 7 and my little one is 3. So I can say 7 minus 3 equals 4, and I keep the sign of my big digit, which is plus. So that's that one over there. If my big digit has a negative sign, so again, I'm going to ignore the signs for a moment. I have 7 and I have 3, and my signs are different, so I subtract. So I'm going to say 7 minus 3 is 4, but the sign in front of my 7, the big digit, is a minus, so I'm going to put a minus here as my answer. So that's just a fun way to do integers. What I do want to show you quickly, and it is quite important if you're going to use this calculator in class, for integers. If you want to enter a negative number, so you want to start with -3, for example, you need to use the negative sign and not the minus sign, and I'll show you why in a second. If I said, like so, -3, okay, now it automatically puts a 0 there. But if, for example, I said 3 minus -6, you can see it will give me an error because it's putting two functions together. So it's asking you to change that minus sign into a negative sign, and then that will multiply it. So it's just a quirk of the sharp calculator. So just a heads up, use this as your value and this as your function, just to stay ahead of the drama. All right, great, fantastic. So then the next thing for integers is the associative and commutative properties. And they sort of do exactly the same thing. When I Googled them to find the right way to explain it, I was like, this is basically the same thing. But anyway, so the associative property is when we group things together first, and then we multiply them out. Whereas the commutative property just rearranges things in different order, whether you're multiplying or adding. Okay, so that's just the two different things. And I mean, for this one, it's more to help with algebra because you can say 2 times 3x. And then if you rearrange it or you group things differently, you can have 2 times 3, which we know is 6, and then times x, which is just 6x. So that's where we would use the associative property. Where we use the commutative property is when we want to find easier ways to multiply a set of numbers together or add them together. So, for example, 5 times 4 is 20 is pretty easy. But we could also say 5 times 2 is 10, which is also quite nice and easy, and then times 4, and go like that as well. All right, then the next step is numeric and geometric patterns. Is everyone okay? Are there any questions on integers? You can just wave at me if you're all good and you have no questions. You know that raise your hand sign. Okay, fantastic. Thanks, Mbulelo. Okay, great, awesome. All right, so now we're going to move on to numeric and geometric patterns. Thanks, guys. It's nice to know you're still awake and listening. All right, so the first thing we need to know is it a difference or is it a ratio? Okay, so for linear patterns, this is the same distance between each part of the pattern. In other words, we add or subtract the same thing every time, right? So we can have 2, 4, 6, 8, and 10. You can see we keep adding 2 to every point in the pattern. And then, of course, if we're counting in from a certain point, we keep adding 3 to each point of this pattern. So even though we're not counting in 3, 6, 9, 12, you can see that we could also say 3 times something minus 1 would give us the same pattern as well. All right. And then, of course, geometric patterns, we multiply or divide by the same number each time. So we are then saying 3 times 3 is 9, times 3 is 27, and so on and so forth. Okay, so there's some fun things to do using our table mode, and it talks about the investigation. So let's say, for example, I just want to move my calculator over so I can actually see my patterns. Okay, so we have 3n, so we can't put an n into the calculator, we always use an x for table mode, and plus 5. So in other words, we're starting at 5 and we're adding 3 each time, okay? And then we'll just skip through. We're going to make our start 1 because your pattern starts at term position 1. So our first term is 8, and then it's 11, 14, and you can see we're just keeping adding 3 each time as well. Now, of course, we could also do this with a geometric pattern, but before I move on to that, Timbakile, where did you get lost from? Because we've just started patterns, so I think I'll just continue from there. You can always watch the video again to catch anything that you missed as well. So what I want to do is, let's look at this pattern. So we've got 11, 14, 17, which I think is the same pattern that we investigated just now, right? And we can see that each time we're adding 3 to the pattern. So we're going to add 3 here. Then to find the C, or to find the thing that we added, oh, okay, I'll come back to that in a second. To find the thing that we added, we are going to just say 11. So we're just going to go backwards by 1 and say 11 minus 3. And that will give us 8. So our pattern is going to be 3n plus 8. Okay, so it's not quite the same pattern as the one that we did just now. I'm just going to clear this because otherwise it will go all the way through as well. See what I mean? There we go. So we can now check that this is the correct pattern by typing it into the calculator. So I'm just going to press on twice, and then to make an X, you just press this RCL button twice. Do you see there's a little blue X on top of it? So you could either say alpha X, or if you're really lazy like me, just press this button twice, which is quicker. And then we say plus 8 and equals, leave my start at 1 again for my first term. And there's my pattern as we saw it before, 11, 14, 17. So I know I'm on the right track. Now, what's nice about using the table mode for a pattern is if, for example, I want to know what the 10th position in the pattern is going to be, then I can just scroll down to X is 10, and I can see that my 10th number in my pattern is going to be 38. Then, of course, you get the geometric patterns. Now, this is actually more of a metric way of writing this, or yeah. But you can see that the common pattern is we are multiplying by 4 every time, right? And our first term is 3. So we start off with 3, and all we're going to do is say 3 times 4 to the power of n minus 1. Okay, now if we were going backwards, we could also use this method. So we were multiplying by 4, so we go backwards, so that it would be 3 over 4, and then we can say times 4 to the power of n. So both of those are correct ways of writing them, just mathematically, algebraically different, basically, but it gives you the same answer. And again, we can put this into the calculator. Sorry, let me just clear these quickly. We can put this into the calculator and check again. So I'm just going to press on twice, and our formula is 3 times 4 to the power of x minus 1, right? We could do it both ways. In fact, let's do it both ways just for fun. So I'm going to have 3 over 4 times 4 to the power of x. And you'll see that when I go through this, my answers will be exactly the same because they are algebraically identical. So there you go. Just a fun side maths note. It's great for explaining exponents as well. All right, awesome. So there's the steps for how to do what I just did on the calculator. And we are going to move on to functions and relationships. Everyone happy so far? Great. Awesome, awesome. Okay, so when we look at functions and thanks, Mbolelo. When we look at functions and relationships, we look at input and output values, and how they are placed into tables in flow diagrams and of course into our formula. And we need to be able to give the other two, the table or the flow diagram or the formula, from any of the ones that we have been given. And this really follows quite nicely from the patterns that we've just been speaking about, because you've got the formula in the pattern and you can again create what is my term position, what am I doing to it, and then what is my term value. It's exactly the same thing. So it's important for the students to see that the maths is very similar. We're just naming it different things and applying it differently, basically. So again, I'm not going to do this again because you've sort of seen the table already in action. So we can again investigate a pattern or a formula or a table and do the same thing for a geometric pattern. Do you know what I mean? So the tables, functions and relationships are very similar to number patterns as well, just showing different ways of using them. I'm on a sidebar here, but I do think it's important that students recognize that a lot of the maths is, the underlying core maths is exactly the same, and it's what we name it and how we apply it that makes it different. I say difference in inverted commas, but it's a really nice way to show them how to link the link between those two as well. All right. Cool, exponents. So the first thing that we need to look at is scientific notation for the grade 8s. So I'm just going to jump back home and we're just going to do a basic exponent calculation. So there's two ways to do the exponent on your calculator. The first is to use this very antiquated E, and you'll see it just comes up with, well, E to the power of zeros is 10. Okay, so that's just, it just means times 10 to the power of 1, right? Otherwise, you can use this option here, times 10 to the power of 1, or you could just say 10 to the power of 1. So it's really up to you, however you want to do it. All of those calculations will wind up in scientific notation past a certain value. So if we did, for example, 3.4 times, I'm going to do this version just to show you the difference, times 5. And then here I'm going to say times 7.9. And then I'm going to do this version times 10 to the power of 6 and equals, and there you go. So that would be your X, and you can see we're still using the E here, which just means times 10 to the power of, and then if it is a negative scientific notation or a negative exponent, it will just have negative in front of that number. Now, something that you need to know is how to set up your scientific notation. So we're just going to press setup, and then 1 for FSE, which stands for Fixed Scientific and Engineering. And we're going to choose 1 for scientific notation. And then, of course, if we want, because in our calculation, we've only got 2 significant digits or figures, so we're just going to put 2 in, and you can see that it rounds it off automatically for you. If I want to go back to how things, my normal calculations, and not have scientific notation answers the entire time, I can either reset the calculator, but then you lose everything else, or you can just say 1 for FSE, and we're just going to choose 3 for norm 1. Now, norm 2, basically, if you're negative, like past negative, a very small number, it will automatically convert all of your negative numbers into scientific notation. So that's just a heads up on that one. So norm 1 is the one that we normally use. Sorry, that's just terrible. But just so that you know the difference between those two as well. Okay, great. Now, we were discussing exponent laws yesterday when we did this workshop for the first time. And I was saying how nice it is to use the calculator to prove your exponent laws. So, for example, if I was teaching the multiplication law, okay, so I have 2 to the power of 3, right? And if I times it by the same base, we know that when when we have same bases and we multiply, we add the exponents. So let's prove that to our students. So here's 128, right? Then I can also say second function and p fact, and it will show me 2 to the 7. Now we can see 7 is made up of 3 plus 4. So if I did this as well, 2 to the power of 3, plus 4, like so, and equals, it will give me exactly the same answer. And again, if I prime factorize it, I will see exactly the same answer. So it's a really nice way to demonstrate the multiplication rule to your students. Now, another nice thing that I actually just thought about yesterday when we were doing this workshop is demonstrating the rule where anything to the power of 0 is 1. So on our table mode, we can put in anything, which is our x, to the power of 0, and press equals, and okay, 0 to the power of 0 is undefined. We don't have that. But anything to the power of 0 is 1. And if we go down this table, it doesn't matter for how long we go down this table, every answer is going to be 1. And even the negative integers, because remember now it brackets that, so it's in brackets, negative 1 to the power of 0 is still 1. And you can go up this way. So one of the nice things about the sharp calculator, particularly the table mode, is that it is unlimited. You have an infinite number of coordinates that you can look at. So it makes doing investigations a lot of fun. So I am, due to a special request from Haley, going to set up an exponents investigation for grade 8. And I'm hoping to have it ready sort of in the next 2 weeks or so for you once the admin side of things is done. So just a nice heads up on that one, if you do need one for your grade 8 learners. Okay, great. Then squares, cubes, and roots, exactly the same as what we covered in decimals. So I'm not going to repeat myself here because you've already seen all of the fun stuff that there is to see there. Great. Any questions there with exponents? We're all good. Sure, you're really flying through today, I must say. Okay, fantastic. So let's talk algebra, our favorite thing. So the first thing that we need to talk about is like and unlike terms. Okay, so firstly, what is a term? Well, a term is a number that is separated from another by a plus or a minus. So a fraction is considered one term. 1/4 is one term. So anything multiplied or divided is still considered one term. So if we look at this one here, this is actually just one term. But if I multiply it out, so 3x times 4, I get 12x. And plus 3x times 5x is 15x squared. Now I have two terms, 1, 2, because they are separated by a plus and there's no bracket. So brackets make the whole thing one term because it's multiplying. Okay. Now the next thing to think about is that like terms have the same variables and the same exponents. So 3x and 5x are like terms because the variables are the same and the exponents, 1, are the same. But unlike variables, so even 3x and 5x squared are unlike because x squared is actually x times x. So there's 2 x's here and only 1 x here, and you cannot add the two of them together. It's like putting bananas into, I actually don't know because I've been adding bananas to everything lately. So, okay, so there's that. Then of course, the other theory that we need to go through is your coefficients, which is the number and or variables attached to the variable you're looking at. So we can say if we have 3xy, right? And we say, what is the coefficient of y? We can see it's the thing in front, 3x. But if I ask you what's the coefficient of x, you need to pay attention to the fact that y is actually attached by a multiplication or a divide. So that's also part of the coefficient. So 3y is the coefficient of x. So just a heads up, because that's quite a common mistake that students tend to make, especially when I was doing extra maths with them. It's something that they struggle with. So don't tell them it's the thing in front of the variable you are looking at. It's the things that are attached to the variable by multiplication and divide that makes it a coefficient. A constant is a value that doesn't change. And there's a really nice way to explore this again on the calculator with table mode, magical table mode. So say, for example, we have 8, right? And we're just going to put 8 into our first function. We're not doing anything to 8, it's just 8, right? And in my second function, I'm just going to say x plus 8, right? And equals. And let's just go through. So in my first one, I've just got 8, and you can see nothing is happening. It is staying the same, and that is your constant because nothing has changed it. It's not attached to anything that can change it. It's a constant. But if we look at this answer 2 column, we can see that it is changing the whole time depending on the input that we put in from the x, right? So because we had x plus 5, or x is 5 plus 8 is 13, now it changes the whole time, and that's a variable. So that's just the difference between the two. Again, a nice exploration, just something quick to show the kids on the calculator. You know, when you do things out of the ordinary, they tend to remember it better, especially stories. Tell them weird stories, they love that. And then, of course, your degree is the highest power of your expression. Remember, it's the highest positive power and not the highest any sign power. So just a heads up on that. And then, of course, an expression is a one-sided calculation. So in other words, it's got an equal sign and there's nothing on this end. So it's 3x plus 5x, and you can just to simplify it and you can't go any further, right? Whereas an equation, you can have 3x plus minus 1 is equal to 0, and you can actually solve for something like your x. So you can have 3x is equal to 1 and x is equal to 1/3. So that's just the difference between an expression and an equation. And it's something, again, that it's just terminology that often gets mixed up with the students. And then when they start answering questions, they get all confused and they forget what they can and cannot do. So just a thing on that one as well. And then, of course, polynomials are your number of terms in your expression or equation. So a monomial is a single term. A binomial is 2 terms, remember, separated by a plus or minus. And then a trinomial is 3 terms, and a polynomial is more than 2 terms. I actually need to change that. All right, and then, of course, don't forget FOIL. So it's your firsts, which is these 2 here, and then your outers, and then your inners, and then your lasts. And you can see, hopefully you can sort of see the kitty cat picture that I've drawn here. You know, kids love this sort of stuff. I remember doing it a lot with the kids that we had at Extra Maths. Okay, great. So the last section is algebraic equations. Are there any questions up to here, up to this point? You're all good, happy, still awake? Okay, great, fantastic. So this is the last section. Thanks, Mbulelo. I'm glad you're waving at me. Okay, so let's just look quickly at the highest common factor. Okay, so again, this is just part of factorizing and they need to be able to do it. So, I mean, 85 and 100 is quite a big example, but let's do it anyway. So what you're going to use is second function and 2, and it will give you GCD, which stands for greatest common divisor. Exactly the same thing as highest common factor, factor, divisor, same. Different names, same sort of idea, okay? And then 100, and then equals, and there we go. So the highest common factor of 85 and 100 is 5. And you can also find the lowest common multiple this way, so 85, and we say second function 3, and 100, and equals, and then we get our LCM. So this is very handy when we are doing algebraic fractions or fractions in general with the students as well. And then, of course, we can also use our wonderful table mode to find factor pairs. This is my favorite thing. So let's, oh, sorry, wrong thing. Let's find a factor pairs of 36, right? So we're going to say 36, and we're going to divide it. I use the fraction button. You can use either divide or fraction, up to you. Put in an x. Okay, so that's what it looks like. And equals, leave function 2. Let's not make things complicated. And leave everything as is. Okay. Anything divided by 0 is undefined, which is where that stripy line comes in. It's It's an important thing just to make note of for the students. It's not because your calculator is drawing funny pictures or it couldn't calculate the answer. Well, it couldn't calculate the answer. That's why it's done that. But it means undefined. You cannot do it. And then, of course, here are all your factor pairs. So we've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So we know 5 is not a factor because the answer has a decimal remainder. So we ignore that and then move on to the next one. 6 and 6 are both factors. And then here we can see we've gone back around 7 and 5, 1, 4, blah, 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 blah. So here we can also see it's not a factor, and we know we've finished because the values are starting to repeat over again. Okay. Now from here, this lends itself very nice to factorizing trinomials. Now in grade 9, you don't actually need to know how to factorize with an A value unless it is a common factor. Okay. So what I'm going to do is I'm not going to go through finding the factor pairs again because it's just 6 and we sort of know them. So I'm just going to write them down here. 1 and 6, 2 and 3, 3 and 2, and 6 and 1. Okay, sorry. Nice handwriting. Okay, so the first thing is to look at the sign in front of the C. If the sign in front of your C value, in other words, in front of your constant, is a plus, then you know that your brackets are going to have the same signs. And to know which sign to use, we look at the sign in front of the B. Okay, so here I've got X, and my signs are both going to be pluses. Here my sign at the back is a plus, but the sign in front of B is a minus. So in this one, I'm going to have just 2 minuses. Right, okay. Now we look at our factor pairs and we say because my sign at the back is a plus, I need to add my 2 factors together to find my middle term, which is 5, right? So 1 plus 6 gives me 7. Not my middle term, so I ignore it, and I look at 2 plus 3. 2 plus 3 does give me 5, so now I have found my factors, and I've very basically got x plus 2 times x plus 3, and I'm now done. I've done it as a very simple example, but I mean it works regardless of the example that you use. It's a really nice technique. Again, here my sign at the back is a plus, so I need to add my 2 terms together to find my middle term, which is 5. So 1 plus 6 doesn't give me 5. 2 plus 3 does give me 5. So I'm just going to fill it in there, 2 and 3 again. Now I'm going to rewrite the factor pairs here. 1 and 6, 2 and 3, 3 and 2, and 6 and 1. Okay. Now for the example where your sign at the back is a minus, you need to have different signs, right? So I'm not going to fill in my signs just yet, and you'll see why in a minute. Okay, so when I have a minus at the back, it means I need to subtract my columns. So because I have different signs, one of my columns is going to be a plus, and one of my columns is going to be a minus. So if I just go through this very quickly, plus 1 minus 6 gives me minus 5, which is not my middle term. So I look again. Plus 2 minus 3 gives me minus 1, which is my term. So here I'm going to use the sign. So it's going to be plus 2. And of course, this one is minus 3. So here I write minus 3. And when you multiply it out, you will see it gives you exactly the same equation or expression. So that's, I like this method. I've showed a lot of students it, and they really like it for its simplicity. Especially when those struggle with the factorizing thing. Now, before I end off, I do want to show you this because we are talking grade 7 to 9, right? So one of the things that they do need to practice is their mental math. So on your sharp calculator, you have a drill function, okay? And we'll just use 0 for math. And all we're going to do is scroll. You can see you've got 25, 50, or 100 questions. And then you can choose to do timesing or dividing or adding or subtracting. All 4 of them together, up to you. For grade 7 to 9, I would recommend this one because it's a better mental challenge, especially because the questions that they're going to do are going to incorporate all of these things all together. Then what's going to happen is the calculator is going to ask you a question. 3 times 4 is 12, and equals, and I get a tick and a new question. If I get the question wrong, which I'm sad is this one, I'm just going to say equals. You'll see the calculator will give me a mark wrong, and it'll ask me the question again. And it's very patient. It's going to keep asking you until you get the answer right. Okay, so if I don't know the answer, I can always ask the calculator. So I'm going to leave this answer space blank and say, I don't know, and just press equals, and it will give me my answer. So next time I see 2 minus 1, I hope that I know that the answer is 1. But it's a learning thing. And I mean, this is a very silly idea. It's because the questions come up randomly. So, 60 divided by 10 would have been a better test. But yes, so it's a really nice way to get them to practice their mental math. Sorry, I actually do want to go back here. Before they, and you can just do it in class or ask them to do it in their car with the parents as they go home. A calculator is an easy thing to take with you wherever you drive, So it's a really great way to get them to practice mental math. And the research shows that students who have strong mental maths in primary school have better matric results. So it's a really, really critical skill to have and something that they can use quite nicely in class as well. And of course, if you have something that you want to prepare or set up before you start your lesson, get them to do 25, 50, 100 questions or have a race. I used to keep a packet of suckers in my drawer, and if they got 100%, it was extra math, so it was easier. On the calculator, then they got to have a sucker for that day. And then they wouldn't give me my calculators back because they wanted to practice so they could get 100% for the next. So it was really just a nice way. It's amazing what rewards will do for kids. Okay, so your answer or your mark, I got 2 questions right out of 25 or 8%. So you can also track how well the students are doing as well. Okay, and Valelo's asked me to repeat this, so I'm just going to run through it again. So all you have to do when you do this drill function here is type in the answer. So 11 minus 9 is 2, right? And then we say equals, and it gives me my next question. So it's just type in whatever the answer is. 33 divided by 3 is 11. So I type it in and I say equals, and you can see I get it 6. I'm doing really well. So 4 times 2 is 8 and equals. So as long as you're typing in the answers, you're going to get a mark if it's correct. If it's not correct and you type it in, let me do an incorrect answer, you'll see I'll get it wrong and it'll ask me again. But because you've already got it wrong once, you won't get a mark for it when you get it right for the second. Okay, so just a heads up on that one. And then, of course, you won't get any marks for asking the calculator what the answer is. Okay, how to get to the drill function. Very easy. So what you do is you press mode, and then you choose 3 for drill. So mode is your magic button that takes you to all of the different spaces on the calculator. And then 3 for drill. And then you can choose. So table, if you, particularly for grade 7, if you have some weak students who are struggling with times tables, this is a nice option. So serial does counting in. It's better for the littlies, in my opinion, but I could be wrong. Or random, and then random just mixes it up. And then table, it only tests a particular times table. So it can test only your 7 times table, only your 6, only your 8 or 9, and you can test anywhere between 1 and 12. Once you have chosen what you want to do, you can just press equals. And then what it will do is give you random multiplication with 8, okay, for example. Your other option, I'm not going to go through the whole thing, is if I say mode and 3 for drill and I choose 0 for math, then math does the plus, minus, times, divide, or all 4 of them together. So you use your left and right arrow keys to choose the type of questions that you want to do, and your up and down arrow keys to choose how many questions you want to do. So if, for example, it's going to take you 5 minutes to set something up, then you just choose 100 questions. Okay. What's also nice is you can set your groups into in your class into an A group, a B group, and a C group, and you say to the A group, okay, you guys are my fastest bunch, you do 100 questions, the B group does 50 questions, and the C group does 25. And hopefully then you've sort of got a class that is all finishing at the same time. And you know who your strong students are, who are super fast, and who your weak students are, who are really slow. And all you have to do is tell them, okay, today you're in A, today you're in B, today you're in C. This is how many questions, and this is what I want you to practice. There's nice ways to get around it without making them feel small. So there we go. Cool. Then some other nice things to do is to solve for x, and we can do that with a linear equation. So you can do it step by step, where we can solve it here. So if I have 4x plus 5 is equal to 1, then I know I can take my 5 to the other side. It becomes -5. So I have 4x is equal to 1 minus 5, and 4x is equal to -4. And then I divide both sides by 4, and I get x is equal to -1. Okay. Now I want to check that I've done the right thing. So what I'm going to do is on my calculator, when it's, you need to make sure that the whole expression or equation is on one side and equal to 0. So what we do is we take the 1 to the other side and make it -1. So you can either do it, you can type it in like this, 4x plus 5 minus 1, or you can simplify it first, up to you. Both of them will work. So let me go back here to table, and then I just type it into my table. So we've got 4x plus 5 minus 1, just to do it the long way. And here I'll do it the short way, just so you can see that both work, plus 4. And we're looking for the point on our table where our answer is equal to 0. And you can see here, it's just going up. So I'm going to look in the other direction using my down, up arrow. And here is 0. And you can see it's exactly the same answer. So x is equal to -1, which is what we got originally. So I know I'm on the right track as well. And of course, we can also do this with trinomials as well. So I don't like to tell the kids so much about this because I feel like it takes away from actually learning the maths. But you know, it's your prerogative as a teacher. So let me show you anyway so that you know. And also, it's really nice just for checking answers and making sure that we're on the right track as well. So there's my trinomial expression, and I'm just going to delete that one. If you want to delete a function too, if you're busy in table mode quite a bit, on just deletes the function so you can type in a new function. Here I'm going to leave this one blank. And here we go. So if I look in this direction, I'm only getting positive numbers. So I'm going to go back up again. And remember, there's 2 x's, so I need 2 answers. So my first x is equal to -1, and my second x is equal to -4. So I've found the answers of my equation. You can see why I don't like telling kids about it. But again, it's really up to you how you use the functions on your calculator. To those of you who've joined us on YouTube, thank you so much for your time. I hope that you found it useful. And if you do have any questions, pop them into the comments down below, and please do subscribe to our channel.